Good evening to all of you. I am Bhadra Kamaladasa, the chairperson of Water Forum of IESL. I welcome you all who join here physically and through the Zoom platform. This webinar was organized by the Water Forum of IESL and Civil Engineering Sectional Committee jointly. So Water Forum, if I briefly say about the historical to this webinar, Water Forum organized a webinar on new development in the sand crisis, global and national, in March 2021. So the resource person was Dr. Misa Hettiarachchi. He clearly explained the limitations of river sand extraction, the problems associated with that, and also the environmental, social, and economic impacts that has caused due to the excessive sand mining. So, and further, he emphasized the studies that shows the excessive sand extraction from riverine, coastal, and terrestrial ecosystems have reached a catastrophic levels in Sri Lanka and also globally. So while organizing this seminar, Water Forum thought it is better to join hands with the Civil Engineering Sectional Committee, as they will be interested in looking at the problem, this issue, in some other angle. That is how we both committees came together, and especially they will be interested in looking for the alternative source for the sand. Then today's event will further discuss this important issue, and we would look at the problem in a more different angles. That is why we have invited many resource persons here to give their views especially from the perspective of their organizations working and in different angles. So on behalf of the organizing committee, I warmly welcome you all again, the resource persons joining online, and also the participants joining here physically and online again. And hope you will participate the discussions actively in the because we will produce, our committees will produce a report after the webinar to submit to the council if they to highlight the issues that raised during the proceedings. So that will be forwarded to the relevant authorities in the government. Hopefully, we will continue this dialogue until our government acts to a suitable solution to this problem. So, without any further, taking up the time, I would like to hand over the podium to the two moderators, Engineer Ms. Kamala Gunawardana, the chairperson of the Civil Engineering Sectional Committee, and also Engineer Manjula Samarasinghe, Secretary to the Civil Engineering Sectional Committee. Over to you both. I would kindly invite both of you to take over. Thank you very much.
Hello, everybody, and welcome to what's going to be a fascinating discussion of what sounds like the most boring topic in the world, sand. Why are we talking about sand, of all things? I mean, personally, I never thought about sand at all until I began investigating what sounded like a completely crazy story about how a farmer in India was murdered over sand. And come to find out, he wasn't the only one. There have been many other killings over sand. And the reason is because this plain old everyday stuff is actually the most important solid substance on Earth. It is the primary raw material that modern cities are made of. Wherever you're watching from, the floor beneath you, the roof over your head, the walls around you are most likely made from concrete, right? Just like every skyscraper, every shopping mall, every apartment block that gets built anywhere from Beijing to Lagos is made of concrete. And concrete is basically just sand and gravel that's been stuck together. So that means the paved roads that connect all those buildings are also made of sand. Every one of the windows in those buildings is made of sand too, because glass is just melted down sand. Even the silicon chips that power your computers and your mobile phones, also made from sand. In short, no sand, no modern civilization. And guess what? We are starting to run out. There is so much demand for sand today that riverbeds and beaches are being stripped bare. Farmlands and forests are being torn up to get at those grains. And in many places, thanks to a lack of regulations and official corruption, a black market in sand has sprung up and people are being assaulted, tortured, and murdered all over sand. We consume more sand than any other natural resource except water, nearly 50 billion tons of it every year. That's more than enough to cover the entire state of California or all of Germany. And the key reason that we need so much sand is this: we are building cities and infrastructure at a pace and on a scale that is way beyond anything in human history. Every year, there are more and more people on the planet, and every year, more and more of them move from the countryside into cities, especially in the developing world. So that means cities are growing at an incredible pace, tens of millions of people a year. And building those cities takes a tremendous amount of sand, especially in the form of concrete. Now, concrete is a great building material, and cities can be great places to live. But in many, many parts of the world, that huge demand for sand is causing massive environmental damage and human suffering. So why can't we just use all the sand that's in the world's deserts? Well, it's pretty much useless, unfortunately. Those desert sand grains are too round and smooth to be used for making concrete, which is the #1 thing we use sand for. We need the sand that is found in riverbeds, lake bottoms, and shorelines. And that is why beaches in Morocco are being stripped down to bare rock, and why the habitats of fish and other aquatic creatures are being destroyed in rivers from the Ganges to the Mekong, and why dozens of people, including that farmer that I mentioned, have been murdered in recent years by sand mafias fighting to keep control of this precious resource. So we're here today to learn from each other how and why this sand crisis is playing out, and hopefully to work towards fixing it, because it is a huge, multifaceted problem, and it's going to require a whole range of integrated solutions. So let's get started. It's time to think about how we can build a world for 9 billion people on a foundation sturdier than sand.
Good evening. Thank you, Injibadra, Chairman, Water Forum, handing over the stage for us, both of us, Engineer Manjula Samalsingha, Secretary, Civil Engineer Sectional Committee, myself, the Chairman, Civil Engineer Sectional Committee. So we both will be conducting this program today. So it's really happy to work with the Water Forum and do this effective program, because this is a very useful program for the construction people especially. So your choice to inviting us to do this as the Civil Engineering Sectional Committee, it was a great opportunity. So appreciate it. Without taking much time, as explained by Engineer Badra, so now the theme is clear, so we will go ahead with this program directly. I invite the resource person to come and take the seat. Dr. Missaka Hittiarachi, Dr. Asri Karnavardana, Engineer Ms. Mudita Priyangvada, Mr. Nalin De Silva, actually Ms. Anita Van Rida from USA, and Professor Anura Nanayakar from University of Moratuwa, Sri Lanka. You are also invited, but welcome you online. Now we have the honor of introducing and inviting the first resource person, in this evening is Anita Vanbreda. And let me introduce with a brief note about her. Anita Vanbreda is a Senior Director of Environmental and Disaster Management of World Wildlife Fund, and having over 20 years experience in conservation and disaster management. In a current role, she leads this organization's work, supporting environmentally responsible disaster recovery, reconstruction, and risk reduction, including international policy, operations, and training. Anita was instrumental in WWF's development of the Green Recovery and Reconstruction Training Toolkit, and has worked with a range of humanitarian and development agencies on disasters around the world. Anita graduated from the Yale School of Forestry and Environmental Studies. She's colleague of the UN Emergency Shelter Cluster Environment Committee of Practice, serves as advisor on environment, disaster risk reduction, and climate change for the Sphere Project, and a member of the OCHA UNEP Joint Environment Unit Advisory Group. Without further ado, I invite Ms. Anita to take over the stage. Over to you, Anita.
Thank you so much. Can you hear me? Hello?
Yeah, we can hear you well.
Okay, thank you.
Thank
I must apologize. I have been traveling the last few days and only just realized a few moments ago that apparently my computer has been damaged and there's something wrong with the camera. So I do apologize for this very unfortunate visual, and I wish I could be with you there in person to join you in this conversation. Delighted to be here. I'm so thrilled that you're having this conversation. It's such an important issue, and I look forward to the discussion and contributing in whatever small way that I can. Thank you for that kind introduction. Dr. Misaka, who's on the stage with you there, he and I work on the Environment and Disaster Management Program at World Wildlife Fund, based in the Washington, D.C. office. The goal of our program is fairly simple. It's to reduce risk and vulnerability for both people and nature. And we're focused on extreme events around the world. We launched this program with the response to the 2004 Indian Ocean earthquake and tsunami. So the start of the program is very much associated with your country and with your region. And a lot of the success, to be honest, of our program, which continues to grow over the years, is based on some of the solid foundation of critical thinking and innovation that came from Sri Lanka. And so I often point to what happened in your country and the response to it as an example of how, we can use nature to reduce risk and vulnerability for people. And infrastructure is key to that process and has been a large focus of the program over the years. We are both part of the infrastructure team within World Wildlife Fund, and that team is looking at infrastructure from multiple perspectives. Dr. Misaka and I look at it from a disaster reconstruction perspective, but building materials have been a critical issue in the program, broadly speaking. And sand is something that we've been looking at and thinking about for a number of years. And the call to action report that we're talking about here and sharing with you here came from a collaboration that we have with Northwestern University and the School of Engineering there. And we worked with them to organize a seminar series, had multiple speakers over the course of a year, and just launched that report late last year. We looked at this issue from a policy perspective, from a practice perspective, and then also from a research and innovation perspective, collaborating with multiple colleagues, benefiting from input from colleagues who are in the room with you there, and would welcome the opportunity to work with all of you to think about where is this issue going in the future, where is innovation required, how can we shift the paradigm around consideration of sand and the use of sand and the impacts that it has on both people and biodiversity and nature. So I do apologize that I could not join you. I apologize for this poor camera quality that I have here today. I'm very much looking forward to learning from all of you and to continue to work on changing the way that we look at sand, the way that we use sand, and building a more healthy and resilient future for both nature and people. So I will stop there and turn it back over to the moderator. And again, thank you for your time and for your leadership on this issue, and look forward to working with you as we go forward. Thank you so much.
Today's discussion that how we start this for this discussion to going forward and what areas we have to address. And then I would like to draw attention for the next speaker today. Before that, I remember that when we are young, that around 2 or 3 decades ago, we discussed sand only for the civil engineering constructions. Today, it has totally different, and now it has spanned to other professions as well. Today, even in electronics engineering, that we discuss for many properties of sand. So sand become a primary raw material for many engineering industries as well as globally. It has now become a global crisis. So that is why this time this kind of report has come forward to think us and brought our mind to a way forward for the discussions and the possible solutions coming out from this problem. So this this global sand crisis, the call to action report discuss basically 3 areas: research, practice, and prepare policy frameworks. If you see Sri Lanka today, the context that sand is not that very demanding raw material because of the prevailing construction industry that we almost see that it is not that demanding. But in globally, the scenario is almost different. If you see the country like India, we can know rapid growth of construction. Many projects are going on. So it is a time that the global scenario to be addressed, discussed, and finally, take the result for the Sri Lankan context. So for that, we have today, we have a resource person, Dr. Missaka Hettiarachchi, engineer Dr. Missaka Hettiarachchi. Dr. Missaka is a civil and environmental engineer by training and profession, and hold a PhD in environmental planning and policy from University of Queensland, Australia. Dr. Missaka is a senior fellow at Environment and Disaster Management Program of World Wildlife Fund, working based in Australia. He was a project management for the WWF and American Red Cross Green Reconstruction Partnership in Sri Lanka from 2008 to 2010 after the Indian Ocean tsunami, and served as the environmental field advisor for the UN Global Shelter Cluster. Following the Haiti earthquake in 2010 and Haiphong Island in Philippines, he has led consultant in developing Sri Lanka roadmap for sustainable housing construction from 21 to 22, which was a joint project of the UN and the Ministry of Housing and Construction Sri Lanka, and also the lead author of the Construction Green Guide published by the Construction Industry Development Authority. Dr. Misek is actively engaged in teaching and research on environmental planning and policy at James Cook University, Australia, and the University of Mortua, Sri Lanka. With this honor, I would like to invite Dr. Misek to give some broad eye-opening and for this global scenario of this crisis. Dr. Misek.
Thank you very much, Engineer Manjula, for that very generous introduction. And also, I take this opportunity to thank the Civil Engineering Sectional Committee and the Water Forum for giving, on behalf of the Environment and Disaster Management Program of the World Wildlife Fund for giving us this opportunity. Unfortunately, I have to start by saying Sri Lanka is a global pioneer in the sand crisis. Probably a reputation that we might not want to have, but I think from early 1980s, if I'm not mistaken, we have been taking the brunt of this. Sand-related issues, environment and social issues are related to over-extraction of sand. Few decades back, in most countries, although we were very much aware of the problems related to sand over-extraction, in most countries in the world, it was not seen as a problem, not even imagined as a problem. Today, it's a lot of experts, both from the environmental field, environment management field, as well as the construction sector, agree that it has become well and truly become a crisis of global scale. That's why the Environment and Disaster Management Program of the World Wildlife Fund, which is based in Washington, D.C., USA, and the Northwestern University in Chicago, USA, we got together to conduct a global seminar series on the sand crisis, and then came up with this global call to action on the sand crisis, which was developed not only by the two organizations, but a number of other international partners, including the Global Sand Observatory of the United Nations Environment Program. So I will focus my attention in this presentation mainly to the main tenets or the principles which this report outlines, and then start with a basic introduction to the architecture or the anatomy of the sand crisis. Now, one problem like with any other, what we call in the environmental management sector, the wicked problems, right? Which, you don't know where to start and where to start and where to finish, right? Defining the problem itself is a problem. And so, like with any other wicked problem, the sand crisis has many facets, and we have so many experts, including ourselves as civil engineers, who are grabbing the problem from different sides, like that famous story about the two blind philosophers, the 7 blind philosophers who tried to explain how an elephant looks like. So we have a sectoral approach to the problem. So what we try to do with the call to action report is to provide an integrated framework to look at and understand the sand crisis. Now, as the video by Vince explained very beautifully, or I don't know whether it's right to use the word beautiful, but very starkly and very clearly, there is a global sand crisis. As Engineer Manjula said, like our neighbor, India, has become an epicenter of that problem. And construction sector, unfortunately for us as civil engineers, is the largest contributor to this crisis. If you see the users of sand, the main users of sand, great majority of them, or the biggest volume of sand users, of sand go as inputs to the construction industry, mainly for concrete and block work, but also for land reclamation, glass, and so on. Other sectors, there are users in the other sectors as well, but they are quite insignificant when compared to the construction demand. Now, if you look at the global patterns of consumption from 1970 to 2010, unfortunately, there's I couldn't find any more recent data on the raw material consumption. But if you see like this, out of different types of raw materials, non-metallic minerals, which includes the bulk of which the bulk is construction minerals, which is rock and sand, the growth of that far exceeds any other type of raw materials, including the biomass, right, and including fossil fuels and so on, right. This is a bit dated, but also more clear presentation of that. So if you see, starting from the 1900s, if you see the rate of increase, the type of raw materials of which the consumption has increased at the highest rate are the construction minerals. They far exceed, the rate far exceeds any other, including fossil fuel energy carriers and so on. So clearly, there is a rapid increase for the demand for construction materials, of which sand aggregate forms the bulk, of course. And then that demand comes mainly from the construction sector. It is Sri Lanka's case. This is a projection that we did for Sri Lanka Roadmap for Housing, Sustainable Housing Construction, which was published last year, which is a joint project of the UN and the Ministry of Construction, in which I had the good fortune to be a part of. So according to our predictions, these are projections. River sand again is the material which would form the bulk of the raw material requirement in the next 30 years, or 20 to 30 years. Sea sand is also catching up, like not only river sand, but sea sand is also catching up, along with cement and other materials. So this is a problem that is going to grow, as Engineer Manjula said. Like right now, we have like some breathing space. Probably this is an opportune time to take this into discussion, because of the unfortunate economic situation that we are facing. The construction industry has slowed down. Probably this is a time that we could sit back and prepare for the avalanche that is coming, because we are all looking at like expansion. The port city is coming up, and we are all looking forward to the economic expansion in next year or so, which should invariably come with a explosive demand for sand. Now, if we look at the problem, I don't have to explain what is sand for civil engineers, but just to put it in context, so sand is mostly used as fine aggregate. There are other materials which can be used as fine aggregate as well, but in Sri Lanka, mostly river sand is used as fine aggregate. Unfortunately, most naturally occurring sands, of which the bulk is formed by sands in deserts, And here in Sri Lanka, of course, we don't have deserts, but the dune sand also has the same quality because of the nature of the grains and particle size distribution and so on. So definition of the sand, it's the granular material that falls between the number 4. Oh, something happened. Okay. Number 4, ASTM number 4 and number 200 sieves, which is from particle size of 4.57 millimeters to 0.075 millimeters. So anything which practically falls within that particle size and has a granular texture can be used as and then has the strength, can be used as fine aggregate. But in Sri Lanka, we are very much used to using river sand. So type of fine aggregate, in Sri Lanka, it's the mainly it's river sand, but there are other alternatives such as crushed rock, crushed gravel, pit sand, dune sand, sea sand, of course, is catching up, and so on. But now, if we take river sand, it's very easy to forget that it's actually an environmental flow. Right? Once it is taken out of the rivers and put in piles, we think it's something static. But sand is formed over millennia of geological formations. Normally, in a watershed, sand is formed in the upper watershed areas by the withering of the rock. Right? Mostly in Sri Lanka, it's quartz-based rock. But I think if you take like Himalayas, where quartz-based minerals are a little bit less, there are other minerals forming sand as well. So it is Mrs. Zanayak is here who would be able to explain a bit more in detail later about the process, but it is due to the withering process, mechanical, chemical, it forms into these smaller particle sizes, and then it flows through the river channel. But it doesn't just flow as inertly. Along the way, this sediment forms, contributes to the river morphology, right? It creates the banks, and then it creates, it regulates floods. In that process, it creates wetlands, and especially in the nearshore areas, right? Sand dynamics become very, very active, right? Creating delta, creating estuarine features, and also the coastal areas of which the sand sediment plays a big part. So sand is not just a stationary inert material, it's a dynamic flow in aquatic and terrestrial ecosystems. Altering the sediment flow, because of that, if we take out sand from a river system, we alter the sediment flow, it can alter the other components of that ecosystem. So because of that, there is a sustainable rate of extraction, sustainable amount of sand that can be taken out from a given river system. Beyond that, it will start creating problems. That is what we are experiencing. All the major rivers out of our 103 basins, I think almost all are facing sand-related issues. Now, just very quickly, I don't want to go into too much detail into this. This sediment flow, the best model that we have to explain the relationship between the water flow and the sediment flow in a stream is called the Lane's balance. It's, I think, E.W. Lane, an American hydrogeologist who came up with this. What it says is actually the particle size and the flow of sediment is proportionate to the slope of the stream and the flow of water, right? So what happens here is it's actually a balance of sediment and water that in a river, right? if it is in equilibrium, the sediment that is generated upstream would exit the stream and nourish the beaches and the coastal areas. So the problem comes when we take some of the sediment by sand mining out of the river system, right? And that tilts this balance, right? And when that tilts, it goes into this degradation stage of the equilibrium. So it takes away sediment from the system, right? And which causes bank erosion, river bed incision, drawdown of groundwater, and all these problems. Now, it doesn't stop here. There's other environmental stressors in the upper watershed areas as well, like felling of trees, clearing of land, and so on. The sand mining or mineral extraction also contributes to the degradation of the watershed. Now, what happens with this? When you clear a land, the bare land creates more runoff, right? So more water gets into the more runoff. Not that water in the volume would increase, but like runoff increases, right? And when the runoff increases, that tilts this balance again more, right? Taking it more to the degradation side, right? So it tilts it even further, imbalances it. Now, this doesn't stop there either, because a river basin or a watershed is not just a geological feature. It's not just some feature in a landscape, right? It's a very dynamic, ecological, as well as a social system, right? A river basin or a watershed. So when the land degradation happens, that impacts the livelihoods, right? So that the traditional livelihoods like animal husbandry or agriculture, and we all know by experience now, when the traditional livelihoods are impacted, when poverty hits, when rural poverty hits, that creates labor for all sorts of illegal activities. So that actually become a perverse incentive to illegal mineral extraction and so on. So it incentivizes sand mining, among other things. So this becomes a vicious circle, right? Now, to approach this problem, we have to start thinking about sand as occurring in a sand system, right? So as we discussed, in a watershed, sand is generated by withered rock and flows through the watershed, forms different ecological, geological features in the throughout the channel, but mostly in the lower watershed areas, and then it nourishes the nearshore areas, which sand is a very important component in the aquatic or marine ecosystems as well. What happens is, before it reaches these marine systems or nearshore areas, we take out a bulk of sand from the river itself, or as pit sand, into our social systems, mainly urban areas, and immobilize it here, right? Once we put it into concrete, it doesn't wither, right? For so many, probably hundreds or even more years, it will be immobilized, unlike when it is in the rocks, right? So it is immobilized here, and now we have started taking sand from the coastal systems as well, which is also coming to the social systems and getting immobilized here. So this is the nature of the sand system, right? Sand crisis. Right? We are taking sand, which is a flow, environmental flow, and immobilizing it with our engineering techniques and stopping or reducing that flow. So what decides this fate of the sediments, right? How it flows. Of course, we know there are the environmental factors such as climate and watershed characteristics, but also there are social factors which are value systems attributed to sand socially, economically, and politically. So economic value system is very easy to understand. We all know we take the ICTAD bulletin and CDAT bulletin, and we can see how what are the values we have attributed to sand. Very clearly we can see that, but it's more complex to understand what values we attribute to sand socially and politically. Right? So that is where the challenge lies. If I just try to unpack the sand crisis, we have 4 components in it. I mean, when we are looking at it in a construction engineering point of view, we have the ecosystems which generate the sand, which is governed by the geology of the systems, river morphology, hydrology and climate, and land cover, right? And then we have the construction industry. We have the economic system, right, which decides the housing demand, demand for buildings, development planning, economic policy, which all adds to the sand demand, right? And then the institutional framework, right? Legal legislation, regulations, standards, not only the regulation and legislation about extracting sand, but also our construction industry regulations, standards, and so on. So now, if this is the nature or the architecture, or rather anatomy of the problem, how do we intervene with the problem? How do we positively intervene to make it better? Right. So if I try to add those intervention points into the same diagram, of course, we are talking about this side, like how to improve the ecosystems, how to make it more resilient to the problems that are created by sand crisis, watershed conservation, riparian conservation, like restoring the rivers and so on, impact studies, mapping the problems and so on. And in the construction sector, of course, most attention has now gone into the construction sector. We are talking about sand smart practices, sandless construction, introducing sand alternatives, and so on. But 2 areas where attention is lacking is actually the economic system, right? Because as long as there's demand for construction, there would be demand for sand, right? And whether we could supplant that demand for sand with any other material is highly questionable. So it might be very difficult, but we have to think about like how to control the new building demand as well, without, of course, jeopardizing the economic side of it. That question, it's a hard question, but has to be asked, like how to reduce new construction. I know it's easier as an environmental person, it's easier for me to say this, but and also repurposing buildings and national building material stock taking. I think Dr. Asiri and Ms. Disanayak might be able to add more to that, and including Mudita, because that is a very weak link in our construction planning. If you plan a irrigation project or something, we won't design the project anyway beyond the potential of that stream, right? But when we plan construction, hardly at a national level we consider whether the material demand can be sustained with the existing stock of material in the country. And also effective enforcement of environmental regulations. Partly the provisions are there for that. One thing that is probably lacking is sand smart building regulations and standards. CEDA is here. We know how difficult it is to transform from the older sand intensive, aggregate intensive practices, cement intensive practices we had, going into alternative materials. So that also should be supported through standards, changing standards, and so on. Now, the same problems I want to rearrange. This is the issues are, or the interventions are not new, but rearrange them according to the project cycle and the life cycle stages of a material, because then it's easier for us to understand as civil engineers, because mostly individually as civil engineers we are involved, always we go from project to project, right? Starting from the inception stage, I'm not going through all this. There are different interventions that that can be applied at different stages. It's not just at the design where you do sand smart design, sandless sandless construction, sand efficient, preparing sand efficient specifications and so on. Also not just at the construction stage, making sure that your resource, so like sourcing of material, is legal and responsible, and reducing the wastage and so on. But there are other things that you can do through the project cycle as well. One big thing is what we should, there's no other option we definitely have to look into, is reusing and recycling the demolition waste back into aggregate. Some initiatives have been taken, but it's still very, very slow in Sri Lanka. Maybe Engineer Mudita can contribute a little bit on that. But other countries, for instance, in India, it's quite developed, I think. There are social media-based networks to connect demolition waste to the collectors, and then from the collectors to the contractors and so on, right? Other thing is something that maybe we can look into is better housekeeping practices at sites, and efficient, like low waste construction, as well as going into more prefab items where the wastage would be less when you are doing it in a factory setting. I'm sure Professor Nanakar would be able to shed more light on that. Now, if we look at the same things, if we try to arrange it into the life cycle of a material, because when you look at a material, we normally see it when it is brought to the site, right? But it has a long life cycle from extraction, processing, bringing it into the sites, and finally, like while construction, as well as demolition and disposal. In all these stages, we have to, there are interventions that you can make to make the sand use more responsible and sustainable, right? So even there, also demolition waste collection and processing, developing a network for recycled aggregate is something that we definitely have to look into. There are so many users where this new material can be replaced with recycled material, because we are using, like, even for filling in a site, we are using high quality material that when it can easily be done with recycled material. Yeah. So based on all this, we identified that the key principles of sustainable sand management are: number one, understanding the sand dynamics, right, in a systems perspective, thinking of it as a environmental flow rather than just like a flow, rather than a static material, and source legally and responsibly, reducing sand use, of course, reusing sand, replace sand with alternatives, transparency, accountability, and good governance of sand management, and positively change the social value systems related to sand. Now, that I think is the hardest. It should be social and political, right? And that's where the bigger economic sector interventions can come, which includes rethinking the need for new construction. I mean, of thinking about the need for reducing the bulk of or the volume of new construction. The SAN call to action report, the detailed points that are recommendations that are given in the call to action report was based on these principles. So number one is the policy interventions, policy recommendations. So again, it's a statement which might be difficult as civil engineers for us to kind of digest, but the most, so we are talking about sustainable buildings. We have the Sustainable Building Council, and CEDA has its own sustainable guidelines, and UD has its sustainable guidelines, and so on. But something that we forget is the most sustainable building is the one we don't build, right? So let's keep it in the back end of the mind. Again, it's easier said than done. But keeping that in the back of our mind, then what proactive policy interventions can be taken? Number one, nationally assess the building stock, building trends, and manage demand for new construction. Nationally integrated resource-based, sorry, it should be resource-based planning. So quantitatively assessing the resource availability for construction. There's no national system for that, if I'm not mistaken, in Sri Lanka. And also sustainable sand extraction, but also considering the equity and justice issues. So in the same way that when we say new construction, we should strive to reduce new construction, but we all know economy depends very heavily on the construction industry, right? In the same way, when we say we have to reduce sand extraction or use of sand, we all know there are thousands and thousands of people totally dependent on sand extraction, because it's mostly artisan mining still happening in Sri Lanka, small scale mining. So when we take that decision, it has to be taken with the consideration for the equity and social justice issues which these communities may face. Comprehensive strategic environmental assessment before allowing sand extraction in a given region. So because the sustainable rates might differ from region to region, right? And establish an international body. So this is for the international, at the international level. Already there is the Global Sand Observatory, which is an initiative of UNEP, but it doesn't have any regulatory teeth, or even a mandate through a treaty or something like that. So we recommended through this report that an international body should be established to assess sand demand and extraction and sand flows globally, right? And come up with policy recommendations. The second aspect of the second category of the report were construction industry practices. So there, one major a moot point, a contention point, when we had the global sand seminars also, was this discussion between like the choice between dynamic sand extracted from dynamic environments like rivers or lagoons and coastal systems versus the sand extracted from more static systems such as rocks. So using crushed rock as sand is becoming more and more popular now. The technology to do it efficiently is coming up, but it's also not without its problems, right? Rocks are also, limited in supply. Over mining or over extraction of rocks can also create huge environmental problems, right? So replacing river sand with crushed rock might not be the ultimate solution for this. And then prioritize creating specification and standards for reused and recycled material, which is actually a big roadblock that we are facing right now. Restructure professional education and training. Sorry, I think I should explain it more. So restructuring professional education and training into more sand efficient construction practices, because as civil engineers, like the building, the construction related subjects that we learn, like we or teach, do not include sand alternatives and so on in a systematic way. Of course, lots of research has been done on it. Sorry, there's a spelling mistake in this. Reduce sand and then reduce sand and concrete use and adapt material efficiency strategies in practice, right? And for research, what the call for action report suggests is to improve the understanding of sand systems, mapping, quantifying, identifying the trends, and so on. It's happening to a certain extent, but a lot can be done. Socioeconomic impacts of sand mining, we know a lot about it. It has been recorded not just by research, but also popular media and so on. But an integrated analysis of these socioeconomic effects and how they are interrelated, how they are connected with ecological issues, that is still in short supply. Right? And that also includes expanding the research on ecological impacts of sand extraction. We all know, it's obvious what would be the impacts, ecological impacts, when the riverbeds deepen, when the river banks collapse, when the turbidity increases in water, when erosion happens, and so on. But very surprisingly, there's, as WWF, World Wildlife Fund, we were surprised to see how little research is there on actual ecosystems and mapping of the ecosystem impacts, how much the ecosystems, the extents have been reduced, and so on. So there's a lot of scope for that kind of research. Improve the state of technology transfer from lab to industry. So I think Professor Nanakar would be able to explain more about how much of research is going on about sand alternatives and so on. The challenge now remains to transfer that knowledge from our laboratories into actual engineering practice, which is happening to a certain extent. Dr. Asari might also be able to shed some light on that. And finally, improving the links between the sand extraction and climate change, which is also something which needs urgent attention, because with climate change, more floods are happening, more droughts are happening, which is exacerbated by those impacts are now exacerbated by the sand extraction related impacts, which are also causing bank erosion, floods, and drawdown of groundwater, and so on. So this link has to be properly understood. That's basically my presentation. Just to wrap up with a happy note, this is something that happened in Haiti. This is, I think, 2010, late 2010, 2011. I had the fortune of getting involved in the project, like at the very early stages, but unfortunately couldn't stay longer to see the results. But so in Haiti, when the earthquake happened, millions and millions of cubic meters of debris got accumulated, and that became like a huge challenge for the reconstruction process. So one solution that they came up with was to use that debris in reconstruction. Right? So a lot of material was used as for road bases and so on, where very high quality material is not needed. But this was so they used number one, Haiti was is a very poor country, and they couldn't afford capital intensive machinery. So this is actually a crusher which can be turned by 2 people by hand, and it crushes quite well, right? Like you can crush boulders of this size into smaller sizes, right? And then one person from Red Cross launched this project where they designed a gabion, a house built with gabion cages, where the crushed debris, gravel or rather crushed aggregate, recycled aggregate goes into these gabion cages. Then it's strong enough, it's braced using rebar and so on, and then you can actually apply plaster on top of it, which saved a lot of sand and concrete. So a very low cost example of reusing or construction debris and turning it back into aggregate. Thank you very much.
Thank you very much. And that was very effective and very informative. And I know this time was not quite enough, but I think still we are running short of time. And we had planned to have one discussion for period about 10 minutes, but we thought of shifting that. So we will, I think we'll directly move on to the panelists now. So. Actually, I would like to invite as the first panelist in the event, Professor Andra Nanayakara, who is joining online this evening. Professor Nanayakara is a senior professor in civil engineering of the Department of Civil Engineering, University of Moratuwa. He is also former head of the Department of Civil Engineering in the University of Moratuwa. Further, he is well-known specialist in concrete technology, and he has published many research papers on the same subject. He will share his expertise knowledge related to this discussion because I think most of the event, what we are discussing now, it's sand, and sand is automatically connected with the concrete. And Professor Nanayakara, I think we can read many more, but it's high time for me to hand it over to you. So without further ado, I invite Professor Nanayakara to take over the stage. Thank you.
I hope you all can hear me. Can you all hear me?
Yeah, Professor, go ahead.
Yeah.
Please.
So, shall I on my video? Hope you can see me as well. Yes, thank you very much for inviting me for this panel discussion. And also, first of all, I must congratulate the team who produced this call to action report with respect to global sand crisis. I think is a document compile all the important aspects, all the points that has to be addressed in solving the global sand crisis. I think I will start from the point where Mr. has stopped, even though I don't fully agree with some of his comments. I will highlight those things. Kamala, can I share? I have some slides, so that will help me to have an effective discussion. Can I share my slides? Is it possible? Hope you all can see the slides. Can somebody respond?
Yes.
Yes, sir.
Okay, all right. Now we are talking about the global sand crisis. Now these slides indicate what is the sand crisis in Sri Lanka, right? Now this graph shows the variation of price index of sand and cement. Now these price indices are obtained from the CEDA publication, and Mudita helped me in obtaining these previous data. Now we can clearly see the skyrocketing of the sand price when compared with the cement price. This, of course, I mean that this price index was introduced in 1990. The data was 600 for each material. Now we can see that the cement is somewhat stabilized from, not stabilized, it is increasing from 100 to 500, but sand increased from 500 to 3,500. So why is that? So when the construction industry booms, definitely there's a demand for sand. But not only demand for sand, there should be a demand for the cement as well. But it has stabilized, but not the sand. Why is that? Because the cement, I mean, there are so many suppliers. I mean, if the cement manufactured locally is not sufficient, we can import it. But this is not possible. So we have the limited supply. So when you restrict the river sand extraction, the price goes up. The shortage of supply, definitely the price goes up. Now, when this was, anticipated long time ago, right? This was anticipated long time ago. The first national study was carried out in 1992. And and there was another study about the quarry products. That was in 1995. And that gives a comprehensive, analysis of the availability of the quarry products and also the demand, future demand and projected demand, with and without the peace, right? So this was done before the, during the wartime. And then the interim study, I was personally involved with Presidis in 1999. And then we continued that one in 2002 under Coastal Resources Management Project, where we mainly focus on river sand alternative. So even at that time, the situation was not that critical, right? You can see the situation was not that critical, and we have proposed so many things. Some were implemented, some were not. And this increasing price went up. And the last one where I got involved is this report, a policy initiative produced by CEDA. I hope the Mudita will discuss about this one, what we have recommended. Recommendation for alternative for river sand in construction industry. So irrespective of these recommendations, there was no change in the upward trend. And when this slide was prepared in 2018, the sand price was 16,000 per cube. And you know the today's price is 30,000. Not because of this demand, but because of the other problems, right? The fuel price went up, and so many other the cost of living went up, and because of that one, the sand price went to 30,000 per cube, right? Double the price of 2018. So now to address this issue, I think we must not consider this as the norm or the general trend, right? This is due to the current situation, current economic crisis, due to the current economic crisis. Now to address the issue, right? We must know what is the sand demand for the construction industry, right? What is the sand demand? Now, I think all will agree with me, there's no proper record of river sand mining and the amount of river sand or sand used in the construction industry. Now, we don't use sand alone. We use mostly with the cement. If you consider cement consumption, we have proper records. Cement manufactured in Sri Lanka and also imported to Sri Lanka. We have proper records. Now, if you look at this graph, you can see that there are ups and downs, but there's a general trend of increase of cement consumption. Again, during last 3 years, there's an abnormal trend, right? Because of the economic crisis, the COVID and the economic crisis. The 2018, the sand demand was 6.2 million tons. Now, these figures are based on the cement manufacturers, right? And in 2022, it was 4.52, and they're expecting further reduction of the cement demand. So, and you should not consider that downfall as the general trend. That is a special situation due to this current crisis, right? So if that kind of crisis was not there, this will go up, right? And that should happen. That should happen. The economy should revive, bounce back, and there should be more investment on the infrastructure. I think Mr. said that you must think of reducing the new construction, but I don't agree with that one. Just because of we don't have the sand. Yes, there are so many other alternatives, right? We have to come up with new materials, right? We cannot stop constructing the infrastructure, especially the house builders, right? If you consider the main consumers of cement, I don't know how many of you know about this one. Main consumers are the house builders. 70% of the cement produced and imported to Sri Lanka consumed by the house builders, right? So we must pay attention to this category, right? Not these big projects, right? The massive projects, but the house builders. So we must look after their interest. And the estimation of the sand demand, as I said earlier, there is a correlation between the cement consumption and the sand consumption. So you don't use sand alone. You don't use cement alone. You always use cement and sand together as for masonry work and concrete. Now, if you take a house construction, mainly you get a large amount of masonry work, right? Brickwork, block work, plastering, rendering. Little quantity of concrete, right? So if you analyze a BOQ, you can find out that relationship, right? The amount of sand and the amount of cement used in the building construction. So I came up with this figure. So in 2018, based on the cement consumption, the sand demand was 22 million cubic meters, right? So out of that one, who are the main consumers? The Western province house builders, right? It's about 40%, not on house builders, you get the most of the development, infrastructure development in the Western province. So from where they are getting the sand? I'm not going to discuss more on this one, right? So now all the major rivers are heavily mined. All the major rivers are heavily mined to meet this increase in demand. Now we are getting sand to Colombo from faraway places like Mayangan, about 250 kilometers away from Colombo. So there's a significant negative impact, as Mr. Explained, significant negative impacts on the environment, right? So I'm not going to talk about the impact, environment impact on the rivers and mine. So that is already explained. Now we must think about how to minimize the negative impacts of this excessive rivers and mine, right? One is that anyway, we have to restrict the river sand mining at harmful locations so that we can minimize the impact. As Mr. said, there is a sustainable rate of sand extraction without affecting significantly the environment, without significantly affecting the environment. So under sustainable extraction rate, you know how much volume of sand you can extract. I think GSMB should be able to tell us what is the amount that you can extract at a sustainable rate. And if you know the demand, right, definitely the demand will be less than this one, right? So we have to match this, the deficit. We have to match the deficit of the sand demand, right? There is a sustainable extraction volume, and definitely demand will be higher than that one. So we have to match that one, right? If the construction industry to survive, right? Otherwise, we have to allow the sand extraction without any limitation, so that the construction industry will go here, right? So how to address that issue, right? So there's a deficiency. There's a deficiency in sand supply. So we must think about reducing the sand demand. I think the Nisaka mentioned several things, how to reduce the sand demand. So I also fully agree with that one, right? I fully agree with that, but we must reduce the demand for sand, right? The other one is we must introduce, that will not be sufficient, right? That will not be sufficient. So we have to introduce some alternatives for the river sand to meet the increase in demand. So we'll take how to reduce the demand for sand, right? Demand for sand. I have listed few things, right? Just to highlight, right? So now these are the areas that one can pay attention to reduce the demand for sand, right? I think Mr. K has mentioned most of these things, right? You have to go for precast building construction. The latest development is the modular construction, prefabricated volumetric construction, right? PVC. So that is the latest trend, right? So if you go for precast building construction, you can effectively utilize these precious natural resources. Not only sand, there are so many other resources, natural resources that we are using. To produce cement, we use the natural resources. The aggregate is there, right? So we have to effectively utilize these natural resources. And better quality control, and you can cut down the lot of sand usage. Now in this precast concrete construction, you don't need to plaster it. It's a matter of applying a skim coat. The other one is still, as Mr. said, we are not utilizing the construction and demolition waste to produce recycle, fine and coarse aggregate. Now, you can get a mobile crusher like this, and you can convert this construction and demolition waste to the recycled aggregate, fine and coarse aggregate. Now, I must tell you this, right? I mean, we can have all these ideas, but we must encourage the contractors to use this one. They will not use this one unless there's a benefit, cost benefit to them. So how can you encourage them? Either you must give incentives, right? Incentives to, if you are using the demolition and construction waste in your construction, there will be some reduction, incentive in terms of reduction or percentage of reduction the cost. So now, if I may highlight much more, now we don't need to reinvent what is already there. Now, there are several standards, right? European standard, which allow crushed concrete aggregate. That means from the demolition, concrete demolition, right? So aggregate gained by washing fresh concrete to aggregate gained by crushing hardened concrete that has not been previously used, or recycled aggregate. So there are standards one can follow and still it comply with the relevant industrial standard, right? So the standards are there, but the problem is the people are not using it because it is a hazard, right? Unless you get a cost benefit, people will not use it, right? The other point is now the improve the product standard and workmanship. This is one example, right? Now the bricks available in the market is non-standard price, right? It is the length to width is not twice as the width. So then you get a recess that has to be filled with the extra mortar that is called chopper. So we are unnecessarily increasing the mortar to fill these things, right? If the size is of standard size, then you don't need to put this extra mortar. So this will add to the cost as well as that will add to the sand demand as well. So these are simple things, right? If the block is perfect, then you don't need to do the plastering. You can straight away use the skim coat to get the surface finish. So we must think of the workmanship, right? So most of the bad workmanship you try to cover with the plastering, right? So we have to be quality conscious, right? These are simple things, but this will, have more impact on this sand demand, right? And also the using industrial waste and byproducts like bottom ash and coal-fired, coming from the coal-fired thermal plants. So those are fine aggregates, right? I mean, the bottom ash, the fine aggregate can be utilized to produce, but those are not, sustainable, right? You don't have much bottom ash to produce to meet the entire demand, right? So the small, what you get is a small quantity. So, but these small, additions will have a appreciable impact on the sand demand, right? Okay. Now the other main point is the alternatives for sand means a fine aggregate, right? So we always use the term sand, but in technical terms, it is fine aggregate, right? Now this slide shows the types of fine aggregate that can be used, right? That can be considered in civil engineering construction, right? First one is natural sand coming from the disintegration of the rock, as Mr. explained, right? End up with river sand or pits or land-based sand, dunes and offshore sand, right? Those are all natural sand obtained from the disintegration of the rock. Okay, now if you take the pit or land-based sand, wherever you find the sandy soil, people will again sell as a river sand. Now you can see that they are using backhoes to extract the sand from a coconut cultivation, right? Land close to coconut cultivation created a huge reservoir. So I am not for this one, right? So we are creating another environment issue to find a solution for the environment impact due to the excessive sand mining, right? So mining pit sand or land-based sand, right? Land-based sand, you wash the sandy soil and then extract the sand and release the water, the washed water, that means clay, to the streams and the polluting the river. So that should not be encouraged. The other one is the dune sand, right? Now we have dunes along the coastline, northwest, northeast, and southeast coast, right? Dunes are formed by transporting dry sand by wind, right? These dunes are part of the active coastal system. So we must not touch it. We must not touch it. We can use it, this dune sand, for the construction purpose. So it's very fine sand, and some say that, okay, dune sands cannot be used. No, we can use, right? So that is where that, performance-based design specification comes. Now we have the prescriptive type specification. So if you want to use this fine aggregate, it should fall into a specified grading. If the grading, your sand grading is out, then you reject that one. No, I mean, any grading, with any grading, you can produce concrete or cement. But you have to adjust your mixed proportion. What is important is the performance. What is important is the performance, not the grading, right? So with any kind of grading, you should be able to produce certain fine gradings. We require more water, right? So then there are chemical admixtures to reduce that one, right? So by adjusting the mixed proportion, we can use this even very fine sand. And people are using in that area, the Putlam area, this dune sand for plastering. But we must not encourage to use this dune sand. That does not mean that you cannot use, but because of this impact on the ecosystem, right? The coastal system. Then we have the other natural source of sand, offshore sand. So when you say offshore sand, we are talking about the sand in the deep sea. Sand in the deep sea, far away from the coastline, more than 20 meters deep. So you can find the sand deposits in deep sea. And of course, there can be minor impacts on this coastline, but if you make it far away, then the impact will be minimal. So before extracting, we have to do EIA, right? So it is not that straightforward. There are a lot of problems, right? So to get the approval, right, we have to make sure that it will not badly affect the environment. Now, how about the issues with the offshore sand, right? You get shells in the offshore sand, shells large, the shell fragments. How about the effect of that one on workability of concrete, the permeability? How about the salt contamination, right? So the corrosion of reinforcement, effluents, the white deposit on surface. So we can address those issues, right? The offshore sand processing plant at Mutharajavela. Now, sand extraction and marketing is done by the Sri Lanka Land Development Corporation. So they are the only people who are dealing with the offshore sand. They are doing the dredging and then sieving and washing, right? To meet the requirements, right? So what you get is this one after sieving and washing. You can see that white particles. That is the shell fragments that will not have adverse effect on the concrete or plastering. So there are specifications. For the fine aggregate for concrete and mortar, the SLS standard. SLS standard for specification fine aggregate for concrete and mortar from natural sources that includes the offshore sand, right? So it specifies what is the chloride limit, what is the shell content, so that it will not harm the concrete, right? Okay, so I'm not going for these two, but I will go for offshore sand. That will not be sufficient to meet the deficit, right? We have to go other alternatives. Other possible alternatives is the manufactured sand or MSAT, right? How about the availability of the so-called manufactured sand or crushed rock or quarry dust? Those days we call it quarry dust. That is a byproduct coming from the quarry industry. Then when you are producing the coarse aggregate, as a byproduct, you are getting this crusher fines or quarry dust, right? So the percentage of quarry dust depends on the target product, the 20 millimeter or 40 millimeter aggregate, and the type of rock. Some are very weak, some are strong. So the percentage of quarry dust can vary from 10 to 40%. So at the moment, I think one or two are producing this as a main product, but mainly people are producing the so-called manufactured sand as a byproduct coming from the quarry industry, right? So that is not sufficient to meet the demand, right? Meet the deficit. Now, I have shown here a map of Sri Lanka with some red dots. What are those? At the first slide, I mentioned there was a quarry study done in 1995, right? Funded by ADB and for the Road Development Authority and Ministry of Health, Highways and Social Service, right? Now, in that study, they have proposed what you call super quarries throughout the island to meet the increasing quarry products, not only the coarse aggregate, but also other boulders and larger fragments or particles required for the roads, harbors, and of course the other infrastructure, right? This was not implemented. I don't think that you can find those places. All must be encroached by the people, right? So we need this kind of approach. Right? So this is one promising alternative, right? Offshore sand will not meet the deficit. We need some other alternative like manufactured sand, right? Manufactured sand to meet the deficit. And at the same time, we have to reduce the sand demand, right? I don't think that we can reduce to a great extent, right? So we must encourage and go for this kind of alternatives, right? So application of manufactured sand, I think most of the ready-mix suppliers mastered the use of this manufactured sand, right? So some of the ready-mix suppliers use 100% manufactured sand. So I'm very happy about that one. And they have to control these fines, the dust, right? And it is a positive factor to have the dust because that will give you very cohesive mix, right? And prevent bleeding. And still, this is not popular for cement, mortar, and plaster. Can be done. So, but we have to educate the people, right? So, because it is not like river sand. It's not like river sand. So masons are not used to that one. Because of this rough surface, they have to put extra effort to apply the cement mortar. But there are ways of, making it much more workable, right? Chemical or admixtures are there, right? So we need more research on this to promote the sand for cement and mortar, right? Because concrete is already, well established. Already well established, right? How about the specification, right? Not offshore sand, the manufactured sand, same thing same standard you can refer, right? Okay, I'm not going to talk about this one. I think Mudita will touch on this. Action plan. We produce this action plan to promote alternative for river sand. And we have identified the stakeholders and the agency, and we have listed here the action, right? But I don't think, Mudita can, discuss more on this one, what happened to this, right? So to conclude my, remarks, I don't know that I took more than 5 minutes, I think more than 10 minutes. The few things that I want to highlight what the Mr. mentioned in his presentation. One is the projected sand demand, right? He has shown a graph. I think it is not matching with the cement, right? The 2020, I suppose, matching with my figure, but after that one is not matching with the cement demand, right? The other one is, I don't agree with, you must slow down the construction, right? We must find some other ways of, meeting the demand, right? So MSAN is a promising alternative because offshore sand will not cannot cater for the deficit, right? Other thing is we can have all the policies, regulations, but we must implement those things, right? Up to now, we have not seen that happening. Not only implementation, I think one must monitor. There should be a mechanism to monitor whether what we have implemented is addressing the problem. If not, that we have to readjust this one, our policies and methodology, right? So implementation and monitoring should be incorporated in this one. Okay, thank you, and sorry for taking more time.
Thank you very much, Professor Andrew Nanakara, for very insights and gave a lot of details and some areas never thought, I think, by many authorities. I think we are today to call for actions for this report globally prepared for global sand crisis. We have to act on the research and the practical aspect, what Professor said, and a lot of areas. Thank you very much, Professor. Before going for the next presentation, I would like to give the big background why we invite this gentleman for today's presentation. We know with the accelerated development in early 1980s, the necessity arose in industry for the committed research and development work. for the improved technical consultancy and testing services. I think in this time there were rigid processes in the government, and it is very difficult to meet the requirement for these research and development of especially prime raw materials and the requirements of geological and the building that which expect by the government. At the same time, there was a lab in the present NBRO area, NBRO premises, that was managed by the State Engineering Corporation under the leadership of Professor A.N.S. Kulasinghe. Few transformation later, this lab was now become the NBRO. So there are a lot of functions that NBRO is doing. Out of many functions like engaging in applied research and development, play the role as the national focal point for landslide and geohazards, carry out research and provide guidelines on planning and development of sustainable housing and safe human settlement in disaster-prone areas, carry out research and development activities on the utilization of areas with technologically problems, soil, improve alternatives, sources for building materials, product and technologies, provide standard reports on building and construction. There are many functions in NBRO. So that one of these research and research of these especially raw materials that are needed for construction, and as well as the many engineering industry. So understand the importance of today's context of this presentation. We invited the right person. He is the Director General of NBRO, Dr. Asiri Karunavardhana. Dr. Asiri Karunavardhana is the Director General of National Building Research and Organization. He leads the team of multidisciplinary professionals to reduce the losses due to disasters by integrating disaster risk reduction into planning and development process into the country and achieve the visions of safer built environment and sustainable development gains. He has engaged in many large-scale manufacture development projects as a geotechnical expert and authored over 10 peer-reviewed technical papers in the above field. With this note, it is my honor to invite on stage Dr. Asiri Karunavardhana to deliver the presentation. Dr. Asiri.
Thank you, Mr. Manjula Samarasinghe, for the introduction of NBRO as well as myself. I think after listening to the very comprehensive presentation by Dr. Misaka and Professor Nana Ekkara, so very little to speak now. But anyway, as Mr. Manjula mentioned, so NBRO, we have the kind of three main laboratories: geotechnical and building material and environmental. So one of the main tasks is NBRO, as all of you know, we are the focal point for the landslide disaster, which is one of the major disasters in the country. At the same time, so we have a responsibility and a mandate to provide the necessary technical advice and guidance for the construction sector. As you correctly mentioned, that is the initial purpose of setting the NBRO, but now with this disaster situation, so we are taking the disaster mitigation and disaster risk management part, as well as the providing necessary technical advice for the construction sector. So this subject, I think, stand for construction. So I have prepared the presentation, but I think I can omit most of the thing after listening to this presentation. So as I think all these things, Dr. Misaka and the Professor Nana Ekkara has mentioned, from the Sri Lankan point of view, you know, this sand is mainly used for the construction purpose in the concrete, mortar, and plaster, and these things. I think this is already explained. And so one of the things that we want to highlight, as the Professor Nanayakkar also mentioned. So once we have this good, fine aggregates, so we can have the kind of good mixture and get the required strength, durability, and the workability for this concrete. So it's our duty to find out these proportions and all these things. I think, as Professor Nanayakkar mentioned, so in Sri Lanka, there is no way to get the exact quantity of the sand demand. So what we are doing instead of that, so we get the cement quantity, and then we we calculate the what is the approximate sand demand for that one. So based on the 2019 figures, I think this is tally with what Professor Nanayakkar told. So approximately 22 million metric ton we need in the 2019. So that figure gradually increased with time. So how is this construction industry meet this demand? So basically in Sri Lanka, as you already described, so we have the river sand, then we have the offshore sand and manufactured sand. So those are the three main things main sources that we can get the sand for the construction industry. Let's see, I think all these are explained. And so I think these maps, maybe in the GSMB, he'll explain about these sand locations and sand mining rivers. And these problems already discussed. And so now one of the alternative that we are having is this, as Professor Nanayakkar mentioned, this is the offshore sand from the SLRDC. So NBRO is helping SLRDC to maintain the quality of this one. So we are working as the quality assurance agent there. So these are some figures you can see from 2019 to 2020. So if you look at these figures, it's very, compared to the total sand demand, it's only about 3%. You can see these figures are very correct figures. So you can see, even though we have the very large amount of the offshore sand, but the present demand is very less for that one. And then, of course, we have the manufactured sand. So the process already explained. So you can see the pit sand, of course, as Professor Nanayakkar mentioned, so we are not so popular in Sri Lanka. So these are the properties, but what I want to explain this one little bit now, as previous presenters mentioned, so these are the three main sources. And so we did some research on these three main sources in Sri Lanka: river sand, and offshore sand, and manufactured sand, because there are many misbeliefs. I mean, as mentioned in the Professor Nanayakkar presentation, all the major projects, mega projects like a highway construction, they use the M sand to manufacture sand. But I mean, compared to that total amount, that is only 30%, because 70% of the sand are used by the domestic industry. So the main reason for that one, of course, when the international consultant come here, so that is a kind of very good, they have engineering practices and consultant and engineers. So they have some good designs, and they get the required strength, and that they use this M sand, this one, and M sand, and get the required property of the concrete. To get some ideas and to make some awareness programs, NBRO, I think this research was done in 2019 or 2018. So we try to produce the grade 30 concrete using these three main sources as a fine aggregates. So I mean, fine aggregate from the river sand, and the fine aggregate from the offshore sand, and the M sand or crust of sand. And these, I think, CEDA has done this gradation. So we have the lower limit, upper limit, and we make sure. And I think, first this river sand we take the sample from the Kantale, and so we did the grading analysis, and the grading curve was like that. The dotted broken line indicate the envelope, and the blue line indicate the exact one. So this is within the the allowable limits. Then I think the rock sand, the crushed sand we got from some of the popular manufacturer here. So that's also, I mean, the come to the same, within the limits envelope. And this is the offshore sand, of course, from the SLRC plant. So this is also within the limits, and you can see this chart is based on the the Euro standards, BSc standards. And then we did the kind of calculation for the mixed design, and our target was produce the grade 30 concrete, and these are the mixed proportions. And so you can see the water cement ratio, and as Professor Nanayakar mentioned, so it's depend on the the particle size distribution as the shape of the particles. So water cement ratio is a bit different, and the slump was here. And finally, so this is the 7 days compressive strength for each one. And then, of course, this is the 20 days strength. And the permeability and water absorption we have checked. So you can see once you have the correct mixed design and will control manner, the practices, we can achieve the same strength and using all these three materials, three sources, crushed sand, river sand, and offshore sand. So you can see our target was to produce the grade 30 concrete. So we end up with the with this mixed design, crushed sand 41 and the river sand 38, and the offshore sand, of course, it's the area that we need to do some more research. We have the higher strength. So it implies that, so if you use the correct mix proportions, we can achieve the same performance. So of course the durability and all these things are we have considered, but I am going to present only the strength. So this was we shared with the many our awareness program with the SEDA and other people, and we wanted to aware the contractors, and we have gone somewhere, some to some level, but I must say that has to be continued. Otherwise the people always think that the river sand is the best, and because in Sri Lanka, unfortunately, the most of the 70% construction sector is handled by the masons, because they are very comfortable. They always try to be in a comfortable zone, and they want to use this river sand. So if you are going to if you are going to find the solutions, so that awareness has to be done in the local level using all the masons, and I think the SEDA and we have to get together, and all the universities, and aware that this local contract. I think this is the not the C1 contractor, other contractors. So for that, I think we have to have a big role to play if we want to have a good solution for this sand mine problems. So those I think I just want to highlight, because I think so we can have some extra time for the discussion, because all other the things that I wanted to highlight here has already explained by our two eminent speaker. I must say this is Dr. Mr. presentation, because it's a very comprehensive presentation talking about the global things and everything. So we learn a lot, and of course. We did a lot of research with the Professor Nanayakar. He's the one who helping NBRO laboratory all this research, and he talked about the alternative material for the supplement for the sand. So recently we did some research, especially we start the one research with the bottom mash with the advice of the Professor Nanayakar. So we went to this Norochoy plant and we did some research, and we were able to produce this cement blocks using the bottom mash. So now the knowledge that we gain from that research is using by some contractors are producing the block. And now recently, and we got the patent from the NBRO with the help of the Professor Nanayakar, and we use the waste textile to produce the paving blocks to replace in the fine aggregate component. So that's give the kind of superior quality paving blocks which have the superior properties like absorption as well as the kind of hypermeable material. So this kind of research NBRO is doing. I think we have to concentrate on more. This kind of research, and this is the kind of green product. So I think this kind of research NBRO is doing. And for this, for NBRO, it's always trying to do the kind of applied research other than the fundamental research, because that is our aim. So for the sand crisis also, we work with the SEDA and the other institution. So we always there to find the solution for this kind of issues. One example, I think now, recently we have the kind of import restrictions. Because of the import restriction, to check the cement quality, we have to, it was very difficult to get this standard sand. So then we in BRO did some research and we found some sources in the North Thandi and some other areas, and we did some corrections, and now we are producing this kind of standard sand. So this kind of research we are doing, and in future also we hope to do some research which are needed for the construction industry. And finally, I would like to thank IESL for inviting NBRO and giving this opportunity to share our knowledge and experience. Thank you very much.
Thank you, Dr. Siri, for your very concern about the time. And actually, I can understand why Engineer Vadra she has chosen this. It's like same the birds flock together. So Dr. Isaga is the creator of this idea, this team. So I can now very well understand how this team has got together. So, but anyway, Dr. Siri, your speech, your presentation now has given again a summary. So now I am not much towards the material, but actually now I'm more closer to the sand crisis in this moment, right? So now being the only lady female presentation. So actually she represents CEDA. So like that is also a research organization, and they do multidisciplinary things, right? I think out of many, they are doing a lot of advisory services for the construction industry. So I think you all have chosen a best party for this presentation. So, and also you also promote research, right? So I think it's a good choice. I will not take much time. So she's next panelist is Engineer Mudita Priyangwada. She has been working as the Deputy Director for Construction Economics attached to the construction industry at CEDA since 2011. Graduated from University of Moratuwa. Masters in Building Energy also from Moratuwa. She has further obtained 2 diplomas in procurement and contract management from SLID and CEDA. During her career in CEDA, she has taken special interest in river sand alternatives, developing a policy initiative to promote the alternatives. Recently, she has finalized the C&D waste management guideline in line with the National Waste Policy. Further, she has engaged in developing a roadmap for sustainable construction in Sri Lanka. So I will stay at this point and I will invite Engineer Mudita to take the stage. Thank you.
Thank you, madam, for your kind introduction. So I'm Mudita Priyangwada from SIDA. And today my duty is, first of all, I would like to thank Water Forum and IESL for giving me this opportunity to elaborate what we have done on this sand mining control. First, I would like to explain just only one slide. What is our Act, Construction Industry Development Act number 33 of 2014. It is an act meant for development of the construction industry of Sri Lanka, for regulating, registering, formalizing, and standardizing of the activities of the industry, and also provide measures for improvement and well-being of the industry stakeholders such as professionals, manufacturers, suppliers, contractors, craftsmen, etc. Also that include dispute resolution, and we have to work on public safety in construction industry of Sri Lanka as well. So those are the main activities which we are empowered by SID Act. So Function 12X has given the powers to us to promote and encourage the adoption and propagation of new technologies related to environmental friendly, appropriate, cost-efficient, and affordable innovations. So now I'm going to elaborate what we have done so far. Some of the actions are in line with this call for action report. So recent past, we have contributed to develop Sri Lanka's Sustainable Housing Construction Roadmap 2020 to 2050. So it identifies the forecast, gaps and solutions, what we have to do. Further, SEDA actively engaged in the presidential task force and identified the sand demand for 2021 to 2025. Not only sand, but gravel and quarry products as well. So also, as Professor Anayakar told, we have forecasted sand demand for each year up to 2022 based on the cement consumption. Based on our calculations mentioned in this slide, we have produced a cabinet paper restricting river sand use in large construction projects and mandatory use of alternatives. We took lead role in recommending the revisions needed in Mines and Mineral Act to promote river sand alternatives and to curtail river sand mining. So now, as Professor Narakar informed, we have done a policy initiative and recommended alternatives, identified the issues and requirements prevails to use alternatives by the construction industry, had discussions, many discussions with ministries, other stakeholders, quarry operators, requesting to support in increasing production in offshore sand and manufactured sand. Further, we have now developed the C&D waste management guideline in line with the National Policy on Waste Management. So fortunately, now government is going to work on all the waste, recycle, compost, or produce energy. So in time to come, we will be definitely be able to recycle C&D waste and produce aggregates and sand for construction purposes. So additionally, we have developed a green material rating system, paying attention on circular economy. Definitely, it will work on sand. Published a construction grade guide as an environmental guide to construction stage of building projects with the support of World Wildlife Foundation. So in line with the number 4 of the call to actions report, we have specified alternatives for river sand in SEDA specifications, mainly offshore sand and manufactured sand. SEDA has conducted many awareness programs with the support of Sri Lanka Water Partnership to engineers, consultant, technical officers, and also island-wide programs for provincial councils were conducted inviting government technical staff and contractors. So we had demonstrated of applications of manufactured sand. Also now we are working with NBRO and World Bank to develop a national building code of Sri Lanka based on the performance of the buildings to ensure the sustainability of the industry. Up to now, we have taken these actions are and still in progress. Some of the actions are still in progress. So we have a lot of work to do, and this is a global crisis, and we have estimated that we need 144 millions of meter cubes of river sand for development activities of Sri Lanka, and for development activities or construction activities, we may need 55 millions of meter cubes of river sand. Why river sand? It's 95% of the sand demand is supplied by river sand. That's why it always says river sand. So definitely we don't have such resources to extract sand. And if we go like this, if the construction is going to be normalized, so sand is going to shortage and scarce. So the construction cost will be very high and we will be in trouble. So we have to take immediate and lot of actions, paying attention to sustainability of our industry, because our industry contributes around 6 to 9% to the GDP. So this is a very important industry, and we have to work on continuation of our industry and its sustainability. Thank you very much.
Thank you very much, Engineer Mudita Priyangvada from SIDA. I think SIDA has a very vital role under this downturn of our economy. So SIDA is the one that all contractors and the industry experts are joining. This context, I think we can reap the benefit if the geopolitics have changed, that like India, we can see enormous construction progress in the India, especially India and China region. Probably if the geopolitics change, Sri Lanka may have reaped the benefits that probably our economic crisis may have, we can come out. So we have to ready our country, we have to ready for the new constructions, new methodologies, and we should have improved techniques to face the new challenges of the world. As Professor said, that Professor Nanakar clearly highlighted that this is even minor things like if we don't produce the right quality, right size brick, how the waste is. So this is a time that under the contracts of construction industry, we have very small construction right now. Now the time we can implement the policies, practices, and provide and implement what we have researched already, and then our industry will be definitely get beneficial. So before going to this presenter today, I would like to mention why we selected and why invited this gentleman. He's from GSMB, Geological Survey and Mines Bureau. Geological Survey and Mines Bureau was established in 1993. It is mainly involved in promoting the conservation and management of the mineral resources of the country. It seeks to ensure that the mineral potential is realized for the benefit of the country, and the minerals are extracted in an efficient, safe, and environmentally sound way. The major responsibilities of the Bureau are undertaking the systematic geological mapping and assessing the minerals resources of the country. So with this remark, we invited today Mr. Nalin De Silva. Mr. Nalin De Silva presently works as the Director of Mineral Service of the Geological Survey and Mineral Bureau, and has engaged in the formulation of the National Mineral Policy and developing value additions norms for industrial minerals. Reserve estimation of construction raw materials, including sand surveys of the main river basins are handled under this directorate. Research studies are being conducted in the lower Mahavali Basin to assess the impact on the river system due to sand mining. Besides of the mineral-related aspects, Mr. Nalin has engaged in the affairs pertaining to United Nations Conservation of Law of the Sea, the continual extent and the seabed resources. With this note, may I invite Mr. Nalin De Silva for his presentation. Mr. Nalin.
Thank you inviting me for this forum, and I thank the IESL. And I think I'm not going to go with a presentation because we had enough presentations, but I'm going to address the core issues that came up with these discussions. First, whether the sand is a crisis in Sri Lanka. Well, for some years, but I don't think so. But the reason is why we see it as a crisis, because we are exploiting sand at specific confined locations. But if we see all over the country how, because there is a nice graph from 2004, there is a demand has gone up. It is something to do with the regulations, because then the sand transport licenses were introduced, then the the small scale mining in the system has been kicked out of the system. So now we are confined only to the major rivers. So that is the problem. So again, there are alternatives and there are research and all. Yeah, yes, but this results may take some time to come out. So at the end of the day, we have to produce sand for the construction as it is. Let's say at the end of the day, end of the year, it is about 15 million cubic meters per annum. What is the demand is, and again. When I go through the alternatives, I think we miss the best alternative. It is reservoir derived sand. If you consider runtime alone, now it is about the capacity has been filled up to 51%. So it is all silt, sand, and gravel. So dredge it. That is the best way to because we annually collect. I mean, each 10 years we can dredge it. I mean, the Randinigala, Rantambe, these two things. So that is alternatives are there. Then sea sand. Yes, if you think about Port City alone, we dredged about 44 million cubic meters within 1.5 years. And for this, the Adani people will dredge around 22 million cubic meters. It means 2 year entire requirement in within 6 months. So sand is there. Sand is there. We have to find it and find it properly. That is the why if you are just try to extract sand from the lower part of Mahavali, Kallu, and Kalani, there are a lot of problems. The seawater integration and all. But try to understand where the sand is. So if you think about from Manampitiya to Allakantale, about 60 kilometers, all wildlife. At the dry season, there are a lot of small channels divert from the main river, and it is filled with entirely with sand. But if we know that there is sensitive area, have a plan to take it out. So the sand is there, and we are looking for not the proper places. So again, if you think about manufacturing sand, sorry, if you think about the fuel crisis and all, that's not going to be feasible. And again, if you have a truckload of sand from, let's say, from somewhere like Kantale, where the sand mining is going extensively, even that load is given free of charge. It costs about 45 to 52,000 rupees when it comes to Kalam. So again, that is why the marine sand is going to be feasible, but it is feasible only if you dredge it from somewhere from Galle to Chila. So if you dredge it in the eastern coast, there is no way that you can market it in Kalam. So you have to identify the real issues and you have to address it accordingly. So I think as far as I am aware, I have been many places when it comes to sand. Sand is there and looking at right places, but the regulations, the land ownership is the main issue, because these all where the sand are accumulated is under wildlife areas. So there is a problem. But if you want to desilt the Rantambe, laws may not apply, because you have to desilt, because the plan is there, the Mahavali plan is there. Just activate them, because I'm involved in writing a cabinet paper right now to dredge at least at least Rantambe and Randenigal, and we'll dredge it and we'll sort it and we'll sell it. So the sand is there, so you need not to be that cautious with. But the issue is we are not looking at right places. Thank you.
Thank you, Mr. Nalin Silva. Your logic is, and your argument is in a different facet, and you're using your experience. I suppose your presentation was really practical thing, and you showed us how you manage. I think this is what more than the GSMB matters. Your practical input there is very important. So thank you very much for that. Before we wind up, actually, I will make a small note on this about this event. This is very much remarkable today because we all actually we have to avoid these Q&A sessions because we have run in short time as we scheduled for the event because it was so interesting and I think none of you wanted to stop it, but even the presenters were so energetic and you all I think you have a lot to say, but we have to limit the time, so we will see some other occasion, some other time to do a similar thing, right? With that, I think I will, yeah. So I will conclude it like this. We have to accept your participation here with the resource as the resource persons, but just say a word of thank you is, I think it's not enough, but we have a small memento to hand over the giveaway this with the presenters. So I think our online resource person is Anita Van Breda. We appreciate your outstanding performance, presentation, and please accept our sincere gratitude for your presentation. And thank you very much. Also, Professor Nanakar, your input here too is greatly appreciated. We will share our memento with you as time permits in shortly. I invite Engineer Ms. Bhadra Kamaladasa, Chairperson of the Water Forum, and Deputy CEO, Engineer Gunawardana, to the stage. Jointly, we'll give away the mementos. Chamara. I invite Dr. Mr. Hettiarachchi, who gave us an eye-opening, created this eye-opening session with this eminent resource panel. So, yeah, thank you. Thank you. Wait, and Dr. Asiri, please come forward and accept this token of appreciation. And thank you so much. Ms. Mudita Priyanguda. Thank you. Thank you. Presentation and appreciation. Mr. Nalini Silva. Yeah. Thank you so much for your presentation here. Thank you. I think now we have come to the end of the session, and to mark the ending of this event, I would like to invite our engineer Bandhu Kurupu, who is the coordinator of this knowledge sharing session, to deliver the vote of thanks. Thank you.
Good evening, everyone. On behalf of the organizers, I would like to express our heartfelt gratitude with this vote of thanks to everyone who involved with this panel discussion on global sand crisis. Your presence and insightful contributions made this event a great success. And we would like to express our sincere thanks to all panelists, Ms. Anita Van Breda, Dr. Misaka Hettiarachchi, Professor Nanayakara, Dr. Asiri, Engineer Mrs. Udita, and Mr. Nalin Silva for sharing your expertise and knowledge on the critical issues of sand management in Sri Lanka. I would also like to extend my sincere appreciation and thanks to Engineer Mrs. Bhadra Kamaladasa, the Chairman of Water Forum, for co-organizing this event jointly with the Civil Engineering Sectional Committee. Your support and contribution were instrumental in making this event a success. And Dr. Misaka's effort in bringing together experts from World Wildlife Fund and other organizations to discuss this critical issue in Sri Lanka are truly commendable, and we are grateful for your support. We also extend our sincere appreciation to the chairman, Civil Engineering Sectional Committee, Engineer Mrs. Kamala Gunawardena, and the Secretary, Civil Engineering Sectional Committee, Engineer Manjula Samarasinghe, for skillfully guiding this discussion and keeping the session engaging and informative. Also for the guidance and leadership given to make this event successful. And also I would like to thank the IESL Secretariat, the Publicity Department, and the IT team for their support in making this event a success. Last but not least, I would like to thank all the participants who joined physically here as well as online for your support. Thank you very much once again for everyone.
Thank you, Banduka, taking great care of the event and coordinating the session with everyone and pushing us. Thank you so much. With that, I think we will wind up the session and wish everyone a great weekend and have a safe journey back home. And we'll meet up in similar session again. Thank you. Good night.